Exercise 7. In this exercise, we take a look at the functionality within SolidWorks Simulation to allow us to do a drop test. Now in this case, we have a very simplified version of like a cell phone. And we're going to do a test to see what happens when it drops from 6 feet. So using this software, basically we'll go ahead and get started. Just go to File, Open, and then you'll go to the location of your files here. In this case, I'm going to go to the CAD 208 simulation folder, and this should be in exercise 7, and it's the E7 cell. Now actually, before you do anything with this, your best bet, if you're working off your flash drive, to make things run smoother or faster, or if you're working from my W drive that's at the school laboratory, just right click on this and copy, and then go to your C drive temp. And if you don't have one, you could create one. It's not a bad idea. And then paste it by right clicking, paste, and open it up from there. Okay, might say it's an older version. That's fine because I used this last year as well. Now again, there's nothing super complex about this. I did this so we could do it quickly inside the class without having to wait. Depending upon the workstation you're using, it might take a while to actually run the analysis. If you're on a later workstation computer, it will run much faster. But anyway, it's a solid version of a phone, and has some very simple things on it, like you can see the holes and some very basic features. Now what we need to do is, as you can see here, there's a plane. We need to create a plane as though it's falling on. This is like our floor, this plane. You can see this plane 1. And I want to show you how to create that plane. And because typically the planes that we have are all lined up with it, and if you were to use the top plane, for example, and have it land flat on that, that's not very typical that it's going to land perfectly flat when it drops. So that's why we want to create one at an angle. So I'm going to go ahead and hide these. You can just right click on them and click on the eyeglasses from the quick launch. Now what I would suggest doing is select the front plane and start a sketch, and then go normal 2. And what you could do is take the center line tool and glide up on this edge here and click and drag out a line. And you could drag it out rather long if you like. You could actually draw another center line and that's vertical or horizontal and put in an exact angle. In fact, I could do that right now. Pretty simple. Say if I wanted to draw one off of the origin here. And I could just add a dimension with the Smart Dimension tool between the two, and then I'd be able to control the exact angle of descent. So let's say we put in 25 degrees. Okay, once that's in position there, hit escape, and we could actually, if you hold control and select the actual curve of the center line, and then holding control, select the endpoint. Once both of those are selected, you'll see selected entities, line and point. Now you could go to the features, and actually I meant to get out of the sketch, I'm sorry. Hit rebuild first to exit the sketch. And now go ahead and select those, the endpoints and the line. Go to features, over here, and then reference geometry, plane. And what it should do is create a plane at that angle, perpendicular to that angled line we drew. And that will act as our floor, as though it's falling at an angle. Then you could hide this sketch just by clicking on it, and from the quick launch you'll find the little set of eyeglasses to hide it. Alright. The next thing we need to do, looking at the manual here, is we need to go ahead and we've created the angled line. Now we're going to set it up. So we select a new study. So from here we go to the Evaluate Tools. Okay. And from here we actually don't want to use we have the analysis wizard. Don't use that one. Actually, in fact, we want to load up the full-blown version. So if you go over here to SolidWorks, the little arrow to the right, it opens up all these windows. And you could go to, actually let's go to Office Products. It might be in there. There it is. Under Office Products, go to SolidWorks Simulation. You may have to turn off Photo View 360 in our laboratory, as it sometimes seems to, if it's on, sometimes interferes with the SolidWorks Simulation tool. But most of the time, if you're at home, you should be fine. Alright, so we have SolidWorks Simulation active. So we could go to the simulation here, and we could go to Study. Now on the left you'll see several options, some of which we've tinkered with a little bit here and there, but what we're looking to do is find Drop Test. Okay. Hit the green check mark. And now on the left here there's a couple things we have to set up. The material was already set up for us as acrylic, medium, high impact, but remember you could always right click on that and change the material type. Now as far as the setup, you could go ahead and right click and edit define, and here we have a drop height. We want to specify that. Versus there is also an option, velocity to impact. Let's say you're doing an automobile, you know the velocity, how fast it's traveling. You could put in that. How many miles per hour or feet per minute or feet per second, things like that. But we just have a drop height. And right now it's set for millimeters, but let's set it to feet. And from the lowest point, meaning that the very bottom of the part will touch versus the centroid, and we'll set it to 6 feet. Okay, the next thing we want to do is we got to go ahead and, with gravity, leave it at 9.81. That's the specific gravity that we have here on Earth. So any changes would obviously maybe make this more inaccurate. Okay, now we get to select. Okay, so we want to set this up using our angled plane. Now in the book, be careful because actually it shows the top plane as being selected. With that selected, that will unfortunately make it actually land flat. So we want to go ahead and for the gravity here, select this plane. Now you do see an arrow for a direction, it's basically the vector. Go ahead and flip that by clicking on this little icon over here. Hit the green check mark to apply, and now let's go ahead and run the simulation. Now this could take a while depending upon your computer. In this case I'm using an 8-core AMD processor, which could help accelerate things a bit. It has about 8 gigabytes of memory. If you're curious if it's multitasking, you can always hit Control-Alt-Delete and actually see all of the different the CPUs being used here. And actually this one in particular is not multitasking, but we can see the memory threshold is only at 2.2, which is not too bad. So it's not using a whole lot versus some others actually use a lot more. Okay, as you can see, we're at about 95% and we're about 2 minutes and 20 seconds into it, and it's complete. Now as we look at this, we could see that there's some discoloration with the von Mises stress analysis, and we could see a little bit of red. Our yield strength here is all in von Mises, so we could go ahead and change that. In fact, if you just double click on the rainbow there, and over here on the left there's some different options. Actually this is one I was looking for. Let me right click on it and then go to edit definition. Over here you'll see the von Mises stress. If you hit the little arrow, you'll see a lot of different options in there. We're looking actually, instead of Newton meters, we want to go with NPA. And then as far as the other options, we could pretty much just go ahead and hit apply. And the yield strength of this particular material says it was 206. That means that's about the point at which it starts to deform permanently. And we could see we're up to about 140. So that's not too bad, actually. There's no indication here of anything breaking. If we saw something that was like 210, 220, then we'd see that there's something, maybe something's going to possibly bend permanently or chip or dent. Okay. Now let's animate this. I'm going to go ahead and over here on the left we see stress. Right click and then go to animate. And you could see it simulating the impact. Let's slow it down a little bit. And we could zoom up to it, and we could actually see, looks like waves moving over the surface here. If you zoom up very close to that end, you could actually see some flexion occurring, bending in the material as it impacts. Also, there's the displacement test. If you right click on that and show, it tells us where there's movement, in this case millimeters. It's in scientific notation, but if you right click, and as we could see, and here you can see it's in millimeters, and scientific notation just moved the decimal place over, and so there's very little, I believe that would be 0.003 movement. And if we go to the right click and go to edit definition, properties, we could go ahead and specify if we want to see it in inches. And hit apply. And in this case it's 0.001 is the most movement that we'd see in any sort of flexion. The strain equivalent, if you click on that, again it just breaks it down into facets and you see a little bit more detail for each element. And that's about it.